Welcome back to AK Apt Logics. In the previous class, we have discussed about how to write the design of NOT gate using the data flow model or the RTL model. In the above previous class, we have discussed about how to write the design of NOT gate using the structural model. In the today's class, we are going to discuss about design of NOT gate using the behavioral model. Behavioral model. Behavioral model. So I am just saying the changes what we need to do in the design code. The TB will be almost same. There is no need of changing TB. In the previous class also I have just told you what are the changes that are needed to be made for the gate level model to get the data flow model. In the today's class as well, I am going to discuss what are the changes that we need to made in this particular design code to get into to write this particular to make this design code into a behavioral model style. The TB is almost same, and in Verilog we are not going to focus on TB more. We are going to focus mostly on the design code. The system Verilog we are going to focus on the Testbench. So now in this code everything is same. Module name and the port list, everything is same, and the end model is same. Now in between semicolon and the end model you are going to write the behavioral model style logic. How we are going to write that logic means, in behavioral model we are going to have two procedural blocks which are going to executed one by one. Those are always block and initial block. Always block will be used when you need the block needed to be executed forever. When you need that particular block needed to be executed forever, then you are going to use the always block. If you need a block that needed to be executed only one time, then you are going to use the initial block. In the Testbench we are going to use the initial block. Why? Means we need the test cases needed to be applied to our design only one time. We don't need every time, right? We don't need forever we don't need of applying the test cases. We need only one time of applying the test cases and getting the output and just verifying them and deciding by ourselves whether our design is functionally correct or not, right? But we doesn't need our test cases needed to be applied forever repeatedly, no, right? This is not our decide case, so that we have used the initial block in the Testbench. But in the design code we need not gate always needed to be access not gate itself, right? Not for just one time, right? So that you need to use always block in the design code. So I'm going to use the always block. Always at the rate of, this is the syntax. Always at the rate you need to give. At the rate in the sense event in the sense it is, I will tell you, don't worry. Always at the rate. In this particular braces, for the combinational you just specify the asterisk. You just specify the asterisk, or you just specify the inputs. In this case we are going to have input as only A, right? So I am going to give A, or you just specify the asterisk. Generally we specify asterisk in the parenthesis. What does this mean? Means always at the rate of asterisk. Asterisk indicates the inputs in our design. Whenever there is a change in input, then you execute this particular always block. Then you execute the statements which are written in the always block. That's the meaning of this particular always at the rate asterisk. Always at the rate asterisk. We need to use the begin if you are going to have multiple number of statements. if you are going to have single statement, whether to use the begin and end, it's your wish. There is no rule like that, that if you are going to have only single statement, sorry, if you are going to have only single statement, then you shouldn't use begin and end. No, it is your wish whether to use begin and end if there is only one statement. Okay, it's your wish whether to use it or not. But if you are going to have multiple number of statements, you definitely need to use begin and end. Okay, so I am going to use the begin and end whether I am having the single statement or I am having the multiple number of statements. Okay, now in this always block, we can just simply use y equal to bitwise operator a. Okay, you can just simply give like that. There is no any issue. Okay, you shouldn't use as an over here. You shouldn't use as an over here, which we have used in the data flow model. We shouldn't use like that. Why? Because that's the data flow model. This is the behavioral model. Okay, whenever there is a change in input, the always block will be executed. Okay, so let's see the output. Just saving the code. Just saving the code. Run the output. Yeah, sorry, I have done a big mistake over here. There is a one error and one warning. Okay, and the thing is, what is the error in the design code is when you are going to use the when you are going to write the code in behavioral model, right? When you are going to write the behavioral model, always you need to take output as reg data type. If we are not specifying any data type over here in the place of input and output, then by default they are treated as wires. Now in this code, a and y are treating as wires only. Now what I have told you in the um, behavioral model, when we are going to use the outputs in the behavior model must be treated as reg, so that I am going to give reg y. Whether you can able to whether you can give like this, or you just specify over here like this, anything is fine. Okay, anything is fine. Now we can able to say that a is of wide data type and y is of reg data type. Why a is of wide data type means by default it is inputs are wires. By default inputs or outputs are treated as wires. Okay, even though we have not specified a as wide data type, it will be a wide data type. Okay, that's the meaning of default condition. Okay, now we have specified y as reg, right? So it is of reg data type. If you are going to remove this reg, then y is also treated as wide data type, even though we are not going to specify it as wire. Why? Because that's the meaning of default. Okay, reg y, whether we can specify over here or you can specify after the port list like this as well. You can specify anyhow if you wanted. Okay, I am going to specify inside the port list itself by giving the space over here. Okay, okay, till now you understood, right? What is the error and what is the change that we need, that we have done it over here. Okay, let us save the code and run the program. Now you can see the output we are getting. See, we got the output waveform, right? A is 0 from 0 nanoseconds to 10 nanoseconds, and we can observe the corresponding output as 1, And also we can observe A is getting transition from 0 to 1 at 10 nanoseconds point of time, and the output is also getting transition from 1 to 0, okay, at the same instant at the same time instant, which is the operation of not operation. We are getting the not operation from the waveform, right? So let us see the console output as well, or the log output. At the 0 nanoseconds time instant, we are going to apply the A as 0, and we are going to observe y equal to 1. At the 10 nanoseconds time instant, we are going to apply A equal to 1, and we are going to get the output as y is equal to 0. So this is how the code works. Okay, in behavioral model you have different styles of writing. Okay, this is one style. In behavioral model there is another style as well. In the always begin, we are going to use if else. Okay, behavioral model is the high level language like C. It is almost similar to C. We are going to write if else. If A equal to 1, then our y should be equal to 0, right? Else y is equal to 1, right? There is only one statement, so that I have written beside of the if condition itself, and there is only one statement in the else block, so that I have written beside of else in the else block. If there are more number of statements, more than one statement, then you need to use begin and end. In the C language, what we are going to do, we are going to use the flower braces. Flower braces are the uh, replacement of replacement as begin and end in Verilog. Okay, they will begin and end will be the equal to the flower braces in the C language. Okay, so this is one style of writing code. Let me save it and run it. You can see the output same. Okay, this is one style of writing code in behavioral model. Okay, you can again see the same output, right? I'm not going to explain it. Let us just see in the console itself, so you can see the output. Okay, there is another way of writing the code as well. There are so many ways of writing code in the behavioral model itself. Okay, different ways of. Let us use case of A. We need to give it, and you need to use one tick b 0 colon. I will explain this. Okay, first let me write one tick b 0, then y will be equal to one tick b 1. One tick b one tick b 1 is equal to y is equal to one tick b 0. Default colon y is equal to one tick b 0, or we can give like this negation of A, and we are going to end case. So this is the writing code for not gate in case. Okay, case style. So what we have done is we have taken case of A. In the parenthesis we need to specify for which we need to get the output. Okay, for which value change we need to get the output change. For A value change, sorry, for the input A only we need to get the corresponding output Y, right? For the input A change, we need to get the corresponding output Y, right? So that I have specified the A in the parenthesis, and I have given one tick b 0. If A value is 0, one tick b 0 means if A value is 0, then print the output equal to 1, right? This is the functionality of the NOT gate, right? If p value is 1, if A value is 1, then print the output equal to one tick b 0. Default Default in the sense, when no input is applied, I have just written the function of not gate. Okay, and then end case, we need to remember a point. Okay, you need to remember a point, that is, you shouldn't use begin and end like this. Even though if you are going to use, there is no any problem, but you shouldn't use begin and end. Why? Because we have case and then end case, right? So you shouldn't use begin and end. And another point you need to remember is, in after the condition, that is a is 0, if a is 0, if you are going to have multiple number of statements, then you need to specify them like this, in between begin and end. Similarly for the second condition, second case as well, begin and then end, like this. I need to specify multiple conditions in this, conditions in this begin and end. Multiple statements, you need to specify multiple statements, those are needed to be implemented when the condition, when this case is true. Okay, if we are going to have only one statement, then we can simply write like this. Okay, there is no any problem of writing like this. So let me save the code and again see the output. Run the code. See, we got the output, right? We got the same output. A is 0 and then y will be 1 up to 10 nanoseconds after a be becoming 1 and then y is becoming 0. Let us see the console output, which is easy to see, right? See, at 0 time instant we are getting we are applying a equal to 0 and we are getting y equal to 1, and 10 nanosecond time instant we are going to apply a equal to 1 and we are getting the output y is equal to 0. So this is how we are going to write the code. Okay, so we can write different styles in behavioral model itself, using if, using case, using normal method. Like this we are going to write different ways of writing the code, and the tb is always will be same if you're not going to change the module name. For any style of writing, the tb is always same if you're not going to change the module name. Okay, so this is how we are going to see. So I always recommend you guys to have an hands-on experience, then only you can able to have a good knowledge about any programming language. Okay, so let me discuss another style as well, that is using ternary operator, which is the replacement of if. Okay, a is equal to 1, whether you can specify a is equal to 1 or you just simply leave the a. If you are going to leave just simply a, then it is treated as a is equal to 1. It is going to check whether a is equal to 1 or not. Okay, a is equal to 1. If this condition is true, question mark, you need to give this question mark. If this condition is true, when a equal to is equal to 1, if this condition is true, then we need to get output as 0, right? Output y as 0. Y will be assigned with 0, else y will be assigned with 1. This is the ternary operator, which is the replacement for the if else. If you want to write if else in single statement, then this is the replacement for if else, which is the ternary operator. Okay, so this is how we are going to write in the behavioral model. Okay, this is another style. Okay, there are so many styles as well. See the output, you got the same, right? Similarly, the console output also we got the same. Okay, and you can use this ternary operator in the data flow model as well. Okay, for the data flow model, what we are going to do, we are going to just remove the always and begin and all this stuff, and using the assign in front of the variable y, output y. Okay, and you need to remove this range. Okay, always the inputs, always the output will be y for data flow model, because it is needed to be continuously driven by the input. Okay, see, let us see whether we are going to get an error or not, whether when we are going to use the reg, you will definitely get an error. See, no, we didn't get any error. We didn't get any error. It means it depends upon uh, compiler also. So let me change the compiler to cadence xcelium and run the code. It is asking me to validate my account. No, but it's a wrong practice to use reg in the data flow model. Okay, we just remove this reg. Okay, only in behavioral model you are going to mark output as reg. In remaining models you are going to mark output as wire only. It means you are just leaving them without assigning any data type. By default they are taking, they will be wires only, right? So let me run. So this is the output we are going to get. Okay, this is the console output or the log file output. Okay, this is how we are going to get the outputs. So this is all about the behavioral model, and also I have discussed another style in data flow model, which is using ternary operator. Both ternary operator that can be used in um, behavioral model, and also you can use it in data flow model as well. So for the NOT gate itself, we are going to have several numbers of design codes. Okay, that's the point I want you guys to understand. For the NOT gate itself, we are having several number of styles. Nearly 10 styles we have seen, right? So in the next class, we are going to discuss about how we are going to write uh, design of NOT gate using the switch level model. This thing you can't able to find anywhere. Okay, I am going to. Uh, I doesn't mean it doesn't exist. I mean that you can't able to find it in online that much easily. So I'm going to discuss about the switch level model in the next days. Thank you.